And howdy all, it's Mr. Callen coming back to you. Real quick video for May 18. I'm going to make it real quick to save some uploading time. So if I'm talking too fast, please pause, rewind, rewatch, do whatever you got to do. This is for May 18, Compare Real Numbers Day 1. You're almost there, ladies and gentlemen. And so here we go. Brief chat about the kingdom of number that we talked about last week. Remember that we naturally learn to count with our fingers, 1 finger, 2 finger, 3 years old, 4 cookies. Eventually, kids understand you don't do your homework, you get 0 cookies. That would be whole numbers. So 0, 1, 2, 3, every natural number is a whole number. Then we get to integers. Little kids don't understand negative numbers, don't understand owing money or underneath water. But integers are all the whole numbers and their opposites. So 0, 1, and -1, 2 and -2, 3 and -3. Now, naturally, all those integers could be turned into rational numbers. Just write 3 over 1, 2 over 1, -1 over 1. But rational numbers also could have parts, pieces, portions. 3.2 repeated, 1.5, 1 5/10, 2/3, etc. It is irrational numbers that are crazy, ugly, irrational. They go on forever. In other words, they are non-terminating and they are non-repeating. Got a couple examples there in the red. And yes, there are numbers that are not even real off to the right side. 16 divided by 0. You can't split $16 into 0 parts. You can't take the square root of -25. It does not exist. Now, we also explored these mysterious numbers. So for instance, if you're comparing numbers, if you're comparing 2/3 to 11/15, get common denominators, real easy to see which one is bigger. If you're comparing 3 27/100 to 3 2/10, maybe add in a little place value. The trick of it is, what happens if you were to compare 3 27/100 to something like the square root of 14? In that case, we're going to have to come up with a decent estimate. Maybe it'd be 3 8/10. And then you can quickly see which one's going to be smaller, which one's going to be greater. But we are going to have to learn and use our skills from last week to estimate. So on to today's assignment. I'm going to use abbreviations. The first part of the assignment is going to say, all right, are these numbers natural numbers, whole numbers, integers, rational, or irrational? So I'll use different colors as well as abbreviations: N, W, int, R, and IR for irrational. And so we take a look at number 1. Number 1, I see 12 as in 12. You can definitely count 12 cookies, $12, 12 whatever, 12 pebbles. So it's going to be a natural number. It's going to be a whole number. It's going to be an integer that has no parts. It's also going to be rational. After all, you could write any integer as a rational number if I just wrote 12 over 1. So for number 1, it's going to be natural, whole, integer, and rational. On the other hand, for number 3, number 3 is not a natural number. It is not a whole number. It is not an integer because it has a part. It has that half right there. So then the only question is it rational or irrational? Well, I can rewrite 1.5 as 3 halves, 3 over 2, 3 to 2. That's what a rational number is. It's a ratio of 2 integers. And so we're going to write rational for number 3, and that's it. Number 5 looks a little similar to number 1. After all, 8 over 4 can be simplified into 2 wholes. So it's a natural number, it's a whole number, it's an integer, it has no parts. You could also think about it as 12 as 2 to 1. Or, frankly, if I just saw 8 to 4, boom, that's a ratio. So for number 5, it is a natural number, it is a whole number, it is an integer, and it is rational. On to number 7, where we see parts again, so it is not natural, not whole, not integer. Is it rational or is it irrational? Well, we can rewrite -2 wholes and 7/9 as -25/9. -25 to 9 looks like ratio to me. On to number 9. Had to use my calculator here to find the square root of 3. 1.73205080. Calculator runs out of space. That almost always means that it goes on forever. So here I see a number that's non-terminating, non-repeating, and so it is irrational. Same thing for number 11. Whoops, forgot to add the negative sign. After all, it asks for not the square root of 12, but the opposite of the square root of 12, which is going to be about -3.4641016115. Again, calculator runs out of space. So this is going to be a non-terminating, non-repeating number. So that's what we do for the rest. Go ahead and take care of the evens through 12. And then let's move on. Please notice For the bottom portion of the first page, it says no calculator. Without using a calculator, we need to compare these numbers. All right, we can do that. For instance, 8.7 repeated. Maybe I'm going to go one more spot. After all, if I just compared the whole numbers, they both have 8 wholes. If I just compared the tenths, they both have 87 tenths, or 8 wholes and 7 tenths. So let's go one more place. For 8.7 repeated, just write one more 7 in there. For 8 3/4, we know 3/4 is 75 hundredths. And so now we can see that 8 3/4 is less than 8 77 hundredths, or 8.77, even with more parts, point more sevens. On to number 15. 15 is a little tougher for me. 2.5, no big deal. 2 5/10, 2 50 hundredths if you think money. But how about the square root of 6? We have to use that skill. 6 is between 4 and 9. You see that off to the left. So the square root of 4 is 2. The square root of 9 is 3. The square root of 6 is somewhere between 2 and 3. But you know what? 2.5 is between 2 and 3. So we have to do a little better than that. Let's figure out which it's closer to. 6 is closer to 4 than it is to 9. So the square root of 6 will be closer to 2 than it is to 3. It's almost in the middle. So I'm going to say just, about 2 4/10, but it doesn't matter. Even if it were 2 3/10, it would be less than 2 5/10. Therefore, the square root of 6 is less than 2.5. Onward we go to number 17, where square root of 4 and 41 hundredths. Well, wait a second. If that had no decimal place, square root of 441 is exactly 21. So the square root of 4 and 41 hundredths is actually 2 1/10, 2.1. And so we can see quickly these numbers are exactly equivalent and identical. Onward to 19, I think that's maybe one of the toughest problems on this page. First of all, let's deal with 4 1/3. 4 1/3, kind of the same as saying 13/3. If I were to divide those out, I get 4.3 repeating. Negative 4.3 repeating. And so I'm going to just estimate that as about 4 33 hundredths. Not going to be perfect, but it's close. Negative, of course. Then I take a look at the square root of 15. Well, 15 is between 16 and 9. Square root of 9 is 3. Square root of 16 is 4. So it's going to be 3 point something. It's really stinking close to 4. So I'm just going to estimate it as 3 9/10. Excuse me, that's a negative 3 9/10. Now, why is that important? Well, negative 3 9/10 is closer to 0 and all the positives than negative 4 and some parts. And so we're going to say that negative 3 9/10 is greater than, or the square root of 15 opposite is greater than, negative 4 1/3. Pause if you wish, go on to those even problems. No calculator on the front, but you will be using a calculator on the back. And so let's move to using that calculator. For these following problems, you're able to use a calculator. So if I have the square root of 8, I'm just going to go to my trusty decimals calculator, and I'm going to type in the square root of 8. And I'm going to see square root of 8 is 2.82842, blah, 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 blah. Calculator runs out of space, so I'm thinking this is non-terminating, non-repeating, a crazy, ugly, irrational number. But I know it's about 2 82 hundredths, 83 hundredths, 82 hundredths, doesn't matter, so I can use either. And if I were to rewrite this as a square root of 8 is about 2 82 hundredths, I can see that is larger than 2 7/10, or 2 70 hundredths. So we can write greater than symbol. Again, to use a calculator for number 3, negative 7.42. Yes, I know those 2's go on and on and on, but let's just stop at the hundredths place, estimate it, negative 7 42 hundredths. Go to my trusty calculator again. We're going to type in square root of 55. And we see here 7.41, blah, 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 blah. Again, it's going to be the opposite, so I'm going to write negative 7.41. Oh, well, these numbers are really stinking close. However, because this one has a 2 and this one has a 1, that one is going to be closer to 0. Remember, we're talking negatives or opposites. So negative 7 42 hundredths is less than negative 7 41 hundredths. Again, those are approximate, but that tells us that negative 7.42 repeated is going to be less than the opposite of the square root of 55. Remember the negatives. Be careful when comparing negatives. Now, number 25 I thought was a little tougher. If it was just going to the hundreds place, think about pennies, it'd be $2.77. But as soon as I go to my Desmos calculator and type in the square root of 77, I'm going to find something rather interesting. It also has 2 and 77 hundredths. So just going to the hundreds place isn't going to help. So let's add in an extra place value. Let's put another 7 here. Let's go back to the calculator and see 2.774. And yeah, I know there's more parts after it. But right now I can see which one is larger. That 2 and 7 repeated is going to be just a little bit bigger than the square root of 7 and 7/10. Again, you may use a calculator on this. Go to your Desmos calculator for 22, 24, and 26. And onward we go, again, allowed to use a calculator to order the following numbers. And so I'm going to use a calculator for things like the square root of 5. Square root of 5 was about 2 and 23 hundredths. Square root of 3 is about 1 and 73 hundredths. Yes, it went on forever. 5 halves, you might write that as 2.5. And frankly, from there, I should be able to write these numbers in order. But you will notice in the directions it says verify your answer by graphing on a number line. So I'm going to zoom in a little bit here and show you what these numbers will look on a number line. So 1 and 84 hundredths, between 1 and 8/10, 1 and 9/10, you'll see that in red. Square root of 5 is about 2 and 23 hundredths, a little more than that, sure, but at least I can put it a little bigger than 2 and 2/10. See that in blue. 5 halves, 2.5 in green, 2 and 5/10. 2 and 3/10 in purple, right smack on the tick mark, 2 and 3/10. And in orange, square root of 3 is about 1 and 73 hundredths, and that just proves, if you look at the number line, you'll see orange first. Square root of 3 is smaller than 1 and 84 hundredths. 1 and 84 hundredths is less than, whoops, I wrote these out of order. So 1 and 84 hundredths is slightly smaller than the next number, which is the square root of 5. Square root of 5 is a little bit smaller than 2 wholes and 3/10, and 2 wholes and 3/10 is smaller than 5 halves, or 2.5. And we go on to number 29. Number 29, I didn't need a calculator, but I do need to be careful with the negatives. So maybe I skip to the number line first, and I put -3 and 1/100ths in red, just a little past -3. -2 and 95 hundredths, well, that's -2.9, and then another part, so you see that in blue. -2 and 9/10 in green, -3 and 1/10 in purple, and -3 and 5/10 in orange. Now remember, the smaller or lesser amounts are going to be farther away from 0 in the negatives. Therefore, orange, -3 and 5/10 is the least. Next up is -3 and 1/10, and then -3 and 1/100ths. Then comes blue, -2 and 95 hundredths. Then comes green, -2 and 9/10. Beware of the negatives. One last problem, on to number 31. See some square roots again, so I go to my trusty calculator. Square root of 12 is about 3 and 46 hundredths, but this one says the opposite, so I'm going to put that negative sign in front of it. Square root of 13 is about 3 and 60 hundredths. Actually, it was 3.60, blah, 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 blah. But I think right here, that's enough to put these onto a number line. Be careful, because some are negative and some are positive. Now look at the negatives. -3.46, almost in the middle. -3.5 should be exactly in the middle. Now, sorry, my green goes a little too far to the left, but I didn't want to put them right on top of each other. So the -3 and 5/10 is the least, and it is just a little smaller than the opposite of the square root of 12. Coming up is the purple -3 and 5/10, followed by -3 and about 6/10 in blue. So the square root of 13 is the largest. Just a reminder, folks, the whole back side, you may use a calculator. The whole front side, you may not. Well, we'll say problems like 9 and 11, you can if you want. But frankly, if you have a square root and it's not a beautiful integer, it's going to be crazy, ugly, irrational. So if you look at number 8, if you look at number 10, if you look at number 12, you should be able to decide in a snap which of those numbers is crazy, ugly, irrational. Take your time, do well, email or message me if I can help. Thanks, folks. Have a good day.